Hello everyone, welcome to session on AUTOSAR. In this session I would like to discuss topics on AUTOSAR, why AUTOSAR was started by major automotive companies, and what was the reason behind starting this, what led those companies to start a consortium or a standard like AUTOSAR, what were the problems they faced, and how AUTOSAR can resolve those issues. So I will be providing a overview of AUTOSAR, how it started and how it provides solutions for us. Okay, so let's get started. So OEM and tier 1. So why we have this OEM and tier 1 here? As you may know, there are many number of car manufacturers in the world, like Mercedes, like BMW, Volkswagen, right? So basically the manufacturing of a car involves multiple parties, one who manufactures a vehicle and others supplying necessary parts. Okay, so the suppliers, also referred to as tier 1 companies, provide software and hardware parts to original equipment manufacturer. One of the key parts in a car is an ECU, electronic control unit. Okay, so every ECU supports a particular functionality or a feature of the car. Example, brakes, suspension, engine, ABS, etc. There are a lot of features that a car can support, as our car offers to the customer, and all these features are materialized by several components which are called electronic components, right? So after procuring all the ECUs required for the specific model of a car, OEM integrates them and builds a car. So there are many companies which are dependent on each other when we are talking about a car. So a car, the original equipment manufacturer is the one who assembles or sells the cars, but to build this car, it's not the only OEM who makes the parts of the car entirely from scratch, but it takes several components from multiple suppliers, which are all called tier 1s, and take them and build a car, right? So the intention of this slide is to understand that there are several companies which are independent in the automotive industry. Some of them are called OEMs and the others are called tier 1s. Okay, going ahead. So this is just a very small image to tell about the car and the ECUs. So in the left image we have a car, and there is a network of ECUs. The network is represented with the blue wires, and which connects all several ECUs in the car. On the right side, it's an image of an ECU, electronic control unit, which contains a microcontroller and several peripherals. This is just a example for the ECU, but there could be a different shapes or forms for an ECU, right? Then going ahead, so legacy model. So what is legacy model? So before starting of AUTOSAR, so what was even we were seeing several cars even before AUTOSAR was there, so which was called a legacy model for understanding sake, right? So what was the legacy model about? In the legacy model, okay, so there were many suppliers, OEMs involved in making a car, and every supplier had their own way of software design. Okay, there was no common standard for all the platform software developers to arrive at a same standard. So that what was happening, so every supplier had their own way of software design, and there were no common functionality supported by different ECUs, right? So the common functionality in the sense, so there is a network of ECUs, and one ECU and the other is how they communicate. Okay, so the network management maybe, or the communication stack. So the one ECU may support the network management in one way, and the other ECU may support it in a different way. Okay, so there is not much predictability in the behavior of the platform software between or across the ECUs, right? And the software was ECU specific and hardware dependent. Okay, so it was not a generic software which could be used on multiple hardwares or multiple ECUs. and which also makes it not scalable one. Okay, when you have a software which is specific to an ECU or which is dependent on a hardware, so that of course it reduces the scalability. So meaning you will not be able to use that software for a range of ECUs. Right, so this is the legacy model, how it was working. And then what were the challenges of legacy model? When there are different types of software implemented in different ECUs, so what happens when it comes to the integrator being the original equipment manufacturer, the car manufacturer, so it becomes very difficult for the OEM to integrate ECUs, and it is a tedious job for the OEMs, involving more effort here. And also, software designed for one ECU could not be reused for another ECU, though the supported feature is same, because the software is implemented with a hardware dependent coordinate. So you cannot directly use one software component into another software component, because they are dependent on the hardware, and there is extra development time involved in using that code on the other ECU. Okay, so which leads to more development time, and if there is more development time, and which again leads to more cost. Okay, so the challenge, one more challenge was it was not cost effective. And then, so what is the solution for this? So the major OEMs and tier ones and came up together to resolve this issue. So what could we do about it? So they thought and they pondered up for a solution, and they thought, okay, there should be a common standard for a software, for the platform software, right? And they started with AUTOSAR. So to resolve issues in legacy model, OEMs and tier ones came up with an idea of a common standard for ECU platform software that can implement a common means of communicating with each other ECUs in a network, right? Every manufacturer wants to give the best experience to customers by offering new features in their car models. So it means that we are in a car market. So the automotive manufacturers, the car owners, the OEMs want to give best features to the customers. Okay, they want to compete themselves, right? It's a wide market. Okay, so a common standard gives manufacturers a possibility to focus more on application than platform software, and OEMs share common standard for platform software, however compete in the application implementation. Okay, and then, so with this idea in place, so AUTOSAR was started. What is AUTOSAR? AUTOSAR is a worldwide development partnership of car manufacturers, suppliers, and other companies from the electronics, semiconductors, and software industries. It simplifies replacement and update options for software and hardware. The AUTOSAR approach forms the basis for reliably controlling the growing complexity of electrical and electronic systems in motor vehicles. Okay, so in 20 years, before 20 years we have some cars, and now we are seeing much advanced cars, so which basically involves more advanced features or more features to be implemented in car, right? So which again in turn makes the electronic and electrical systems in motor vehicles complex. So this AUTOSAR platform or approach can control the growing complexity or handle the growing complexity of electrical and electronic systems in motor vehicles. And the motto of AUTOSAR is cooperate on standards, compete on implementation. Right. Now, AUTOSAR partners. So who are the people who are contributing to the AUTOSAR? There are 5 types of AUTOSAR partners here. Core partners include the founding partners like OEMs, BMW, Bosch, Continental, Daimler, AG, and so on. These companies are responsible for organization, administration, and control of the AUTOSAR development partnership. And then we have strategic partners. These people are appointed for a period of 2 years from the circle of premium partners and support the project leader team in the various technical, organizational, and everyday processes. And we have premium and development members contribute to work packages coordinated and monitored by the project leader team established by the core partners. And associate partners are making use of the standard documents AUTOSAR has already released. And attendees are currently participating with academic collaborations and non-commercial projects, some universities and so on. Right. So till now we have seen the legacy model. What are the challenges posed by legacy model, and which made the major OEMs to come up with a standard standard for platform software, and who are the partners of the AUTOSAR consortium. Okay, so what basically is the role of AUTOSAR here, or of AUTOSAR consortium? AUTOSAR provides a set of specifications that describes basic software modules, defines application interfaces, and builds a common development methodology based on a standard exchange format. So basically, AUTOSAR provides the specifications how a software should be implemented, how a network management, for example, network management should be implemented, how a communication should be handled in the platform software, right? So how a application software component has to be developed, and all these things are exchanged in the format, standard exchange format, which is AUTOSAR XML, also called ARXML file. And so basic software modules can be used in vehicles of different manufacturers and electronic components of different suppliers, thereby reducing expenditures for research and development and mastering the growing complexity of automotive, electronic and software architectures. So basic software modules can be used across vehicles or across ECUs, right? So this reduce the research and development time for the OEMs and suppliers. AUTOSAR paves the way for innovative electronic systems that further improve performance, safety and environmental friendliness, and to facilitate the exchange and update of software and hardware over the service of the vehicle. It aims to be prepared for the upcoming technologies and to improve cost efficiency without compromising quality. Right, this is a role of AUTOSAR. Right, so we have just told about what AUTOSAR has to offer. It offers specifications and how the components have to be developed based on these specifications. Now, AUTOSAR basically offers two types of platform software. One of them is classic platform software, which we see right now, and the second one is adaptive platform software, which we'll see in a couple of slides later. Okay, so the classic platform software, basically this platform software, you can see this is a layered architecture. The software modules are spread across the different layers. In this platform software, there are basically three major layers. One is application layer, the second one is runtime environment, and the third one is BSW layer, also called basic software layer, right? And this classic platform is a standard for embedded real-time ECUs. Its main deliverable is specification. The AUTOSAR classic platform architecture distinguishes on the highest abstraction level between three software layers that run on a microcontroller: application layer, runtime environment layer, and basic software layer. The application software layer is mostly hardware independent. Communication between software components and access to BSW happens via RTE, which represents the full interface for applications, right? So application or the software components in the application layer communicate with the BSW through RTE. So basically RTE is the middle layer between application and BSW modules. So this is about the BSW layer. And then the BSW is subdivided into three major layers and complex device drivers. So here you can see there are services as one layer, and electronic control unit abstraction, and there is microcontroller abstraction. Services are again divided further into functional groups representing the infrastructure for system, memory, and communication services. Alright, so this is about classic platform software. And then classic platform software also has a important or essential concept, you can say, which is virtual function bus. This virtual function bus is an abstract set of RTs that are not yet deployed to a specific ECUs and decouples the applications from the infrastructure. It communicates via dedicated ports, which means that the communication interfaces of the application software must be mapped to these ports. The VFB handles communication within the individual ECU and between ECUs. From an application point of view, no detailed knowledge of lower level technologies or dependencies is required. This supports hardware independent development and usage of application software. Okay, so VFB, what is VFB? Virtual Function Bus. So when, say, let us say we have a network of ECUs, right? So for a network, say this network is supporting a feature for us, and this feature is basically spread across multiple ECUs. So it means one feature is supported by a group of ECUs. When the application developer or somebody who designs the application, they just think about the feature point of view, not from the which are all the ECUs involved in this. So he doesn't he care about how many ECUs it is going to work, what is the underlying hardware, anything, nothing. So for him it's a feature, and this feature is spread across multiple software components. Okay, to communicate across the software components, there are interfaces, there are ports between them. Okay, so this feature is divided into multiple software components, and these multiple software components through ports communicate to RT and then to the lower level lower layer modules. Okay, so this VFB is basically a group of RTs of multiple ECUs, right? So when this is designed and then when going for a deployment, so this is the software components or the parts of this VFB will be divided and put into a particular ECU or in multiple ECUs based on their relevance. So this VFB provides a overview of all the software components contributing to this feature, which is distributed across multiple ECUs. Okay, so next we have adaptive platform software. Well, what is the need of adaptive platform software when we already have a classic platform software? So like I said, classic platform is used for real-time systems, right? And adaptive platform, what is the necessity for having adaptive platform software? You know, as the time progresses, so we have more advanced features which are being implemented in the cars. Let us take for example automated drive assistance, so wherein the driver temporarily gives the control to the vehicle itself. Okay, he transfers the control of the driving to the vehicle itself. So then what the vehicle has to supposed to do, right? So it has to say it's in a traffic, it has to monitor the data of the traffic signals, and it has to fetch some data from the cloud services for the fetching the maps. Right, so there is a high computing, high processing involved in here. So as to support these kind of advanced features which require a high computing speed and parallel processing, so adaptive platform provides the solution for all these needs. Okay, so adaptive platform software provides an environment for applications that require high-end computing power. Its core is an operating system based on the POSIX standard. Adaptive platform is based on service-oriented architecture and provides service-oriented communication. The adaptive AUTOSAR is developed and written using C++, which is an object-oriented programming language, and the communication protocol which is used is some may be based on the Ethernet communication protocol for the in-vehicle networking. Next, so adaptive platform software, like in classic platform software we have seen the different layers. Similarly in adaptive platform, so this is the overview of the services offered by adaptive platform software. So adaptive platform platform services include update and configuration management, state management, network management, and diagnostics. The AUTOSAR adaptive platform contains both specification and code. So where in classic platform it contains just a specification, but adaptive platform software provides the code as well. In comparison to the classic platform, AUTOSAR develops an implementation to shorten the validation cycle and illustrate the underlying concepts. So this is about basic view of adaptive platform software, right? So we have seen classic platform software and adaptive platform software, right? So then let us have a look at the benefits of AUTOSAR. How? So we started with the legacy model, and then we have seen AUTOSAR is a standard that we think it can provide some benefits to us. So now what are the benefits that AUTOSAR can provide to us? So one of them is the reusability. Why we are saying reusability? So for example, one software component used in one ECU can be used for different ECUs in different vehicles. So as the software component is hardware independent, the same software component can be just plug and play from one ECU to the other ECU. So it is provides a reusability and portability. So as we have seen the classic platform structure or adaptive platform structure, so they are all hardware independent. So the same stack except the MCAL can be used on one controller or can be ported into a different controller. Okay, so it's highly portable and scalability. So with the advantages of reusability and portability, the number of ECUs that a software can be used is exponentially greater, so which supports the scalability. So you can have as many ECUs as possible to implement the AUTOSAR software. And of course, because of the layered architecture and modularity, the maintenance of AUTOSAR module is really easy, and it's highly maintainable. And the integration of ECUs from multiple suppliers is made easier, which in turn reduces the development time and also the cost. So these are the major benefits of AUTOSAR model, right? So just to provide an overview, so we have started with a relation between OEM and Tier 1, just to give an overview. So all of you might be aware of all this already, but just to give a brief overview on that. So we have seen the OEM and Tier 1 relations, right? And then what was the legacy model, the challenges posed by legacy model, and the solution is AUTOSAR, and how the AUTOSAR, what was the idea behind the AUTOSAR, then who are the partners of AUTOSAR, who started it, and what is the role of AUTOSAR, and what AUTOSAR has to offer. There are two types of platform software AUTOSAR offers us. One is classic platform software, and the second one is adaptive platform software. Difference being classic platform software is majorly used for real-time systems, and adaptive platform is majorly used for where the high computing is required and in such applications, right? So, and finally we have seen the benefits of AUTOSAR, right? So we are at the end of the session. So in the future I would be posting some more videos on the different protocols like CAN, FlexRay, and how AUTOSAR supports the various features, services, or the network management, the communication, the ECU management. Okay, so I will be posting more videos on that, so stay tuned. And please provide your any queries or any feedback you have for this video. And yes, see you soon. Take care, have a good day, bye.